Hello guys, sorry about the delay. Let's just get started. Okay, so I thought that if you haven't used this website before, you really should, which is No Brain Too Small. We're just gonna, but I figured that by this time of the night before the exams, it's really just comes down to what sort of questions that you have, and then just we can just clear up anything sort of last minute. So from No Brain Too Small, this is the last minute survival sheet, like literally the last hour before the exam. So I thought it would be a good shout just to quickly go through that. So let's quickly have a look. So with the structure and bonding, topic, I personally just like to talk about, just a personal preference thing. So, Lewis diagram. You need to know your Lewis diagram. Once you know your Lewis diagrams, you can determine the shapes, and sometimes you talk about the bond angles, and then you need to use the shapes as well as the polar bond caused by the difference electronegativity to determine the polarity. Okay, so that's normally like one big section, and then after that you have got a big section on type of solids. So that's just, by the way, let me do the invite now. If you haven't joined the NCEA server, you could, here's the link. If you need to join, where's that invite people button? Maybe Emmy, you can chuck a Discord link. So I actually have shared a like a model answer, like a two A4 pages document on there, which is looking at the solids. You look, so you can go onto there, and I do tend to answer quite a bit of questions on there. Okay, so with the solids, you need to look at the different type of bonding, different type of atoms, and then explain the polarity, the bonding they have, and explain the polarity, the properties, why do they have those different properties. And then the last question is normally look at enthalpy. Okay, so this is like a really good sheet if you are someone that's kind of like just want to quickly go through everything just to make sure that things are going okay. All right, so anyone has any questions in particular that you want me to go through? Okay, so I will just open a OneNote page. I'm just gonna start a new page. Okay, so if you have any questions about any, if no questions, I'll just go through it. But I thought that would just be a good starting point. If you just type in MBE2S and just look at the last minute survival sheet, if you're just here desperate to pass, I think that will be good. Can I do last minute survival for level 3 tomorrow? I don't know, man. I think the level 3 this year are pretty sus, so I don't think you guys need me. So Emma asks, is oxygen more electronegative than chlorine? It's the other way around. So if you look at the number, fluorine is 4.0, oxygen is 3.5, chlorine is also 3.5. So they have the same electronegativity, roughly the same. Okay, roughly the same. Where is this sheet on the server? So that solids sheet is in the level 2 chemistry section that has been pinned, so you can look at that. Okay, so why are alkanes so reactive? Because they have a double bond, and that double bond is very, very reactive. And when do you use Markovnikov's rule, and when do you use NT? Now, first thing first, there's anti-Markovnikov's rule is actually something else, so you shouldn't use anti-Markovnikov. It's called Zaitsev rule, so it's spelled in many different ways. Like I've seen people with Zaitsev, I personally spell it like the Zaitsev, I spell it differently every time. Some people spell with the S, some people spell with the Z. So it just means one way that you can remember, don't write this down, just go rich gets richer. So when you're doing addition reaction, okay, so when you're doing addition reaction, you add the hydrogen to the carbon in the double bond with more hydrogen, and then poorer gets poorer. So when you're doing Zaitsev rule, elimination reaction, so when you're doing elimination, that is when you have got, like, say, something like an OH and H, and then you remove, like, say, there are 2 H's here, 3 H's here, 2 H's here, This is like a carbon, for example. And then when you're removing, you have this OH has to go. Then you have a choice of either removing this H or this H, and then you look at the carbon that has less number of hydrogen. So that's already on lots of the YouTube videos that I've done, so you can have a look at that. Okay, so there's a lot of people asking questions, so I'll just answer these as quickly as I can. How to count the total number of valence electrons again? Tim, tell me you should be sleeping. How do you count the total number of electrons? You just look on the periodic table of elements, like say for example, chlorine, fluorine, fluorine, chlorine, bromine. So these are group 17, so they have 7 valence electrons. Okay. Next one, how to do those temperature graph things. I don't know what you mean by temperature graph things. I think you could talk about reactivity. So temperature graph, it just means one is steeper. This is like year 11 race reaction. Okay. How to count? I already done that. How do you draw salts? What do you mean? How do you draw salts? I can't draw salts. Salts like 3-dimensional salts, or just Na plus and Cl minus? I don't get what the question is asking. How to answer questions about polarity. So polarity, you need to talk about the bonding first. So you need to talk about, so if you're asking questions like that, then I'm assuming that you haven't watched too many of our videos. So if you talk about bonding, this is like a guaranteed question. You talk about why the bond is polar. Okay, so you talk about the polar bond, why is that polar bond, and then you create bond dipoles. Okay, and then you talk about the symmetry. So from the symmetry, if it's symmetrical, then the dipoles cancel each other out. So if they aren't symmetrical, then they don't cancel out. Okay. All right, so that's just, because there's quite a few questions. Can you go over polymers? Polymers, sure. So one thing that I've seen this question on the Discord server just now. Someone give me a question, ask a question like that looks like this, and they don't know how to draw the polymer. Very easy. Just look at that. Put the double bond in the middle. Can you see this carbon is this carbon, and you just copy the rest. All right, and then this carbon is this carbon, so these are just 2 H's, and then you just draw another one of these right next to it, and then draw another one of these next to it. Okay, so what you want to do is that you want to delete the double bond, and you simply join them, delete the carbon as well, and then delete and join them together, and that's it. All right, so redraw them, put the double bond in the middle, and if you were to go back, what you need to do is that you just select the section that's being repeated, copy it out. So just copy this, C, C, H, H, surely you can copy. When you do year 13 organic, you'll need to be able to copy even better. So just do a double bond, and there you go. Okay. All right, if the enthalpy is negative, then it's exothermic reaction. It will positively be an endothermic reaction. Yes, that is correct. How do you calculate enthalpy change? Well, you need to look at the enthalpy. You're asking an excellent question with one sentence. Okay, so you need to look at the amount of enthalpy in kilojoules per mole, and normally they ask you a question like this: A plus B turn to C, and they give you enthalpy number, to whatever kilojoules per mole, whatever that number is, and then they go, all right, I have 10 grams of A, how many kilojoules do I release? So you just need to, it's best that you just start watching. If this question is bothering you, find last year's exam right now, pause this stream, go find the video on my channel about the enthalpy question. Just watch that. You're better off that way. Okay, does a metallic solid and covalent solid have both atomic particles? Yes. No. Yes, they do. Well, not really. If yes, why? So technically solid, you got your metallic, and then you're asking about covalent. So they are made of atoms. So this is made of metal atoms, and this is made of, like, say, carbon atoms. Okay, they all are made of atoms, but these atoms are arranged differently in your metallic structure. That's why I'm kind of like yes, but it's not really an atom, but we do accept atoms. That's the one we look for. But technically, in the metallic solid, you have got these positive nucleus, which doesn't move, and then you got the electrons that go wee randomly moving around, and that gives you metallic bonding. Whereas covalent bonding is just like carbon bonding to 4 other carbons, and then these 4 carbons bond to 4 other carbons, and this just is one of those examples. So that's just made of atoms. How does double bond affect polarity? Double bond does not affect polarity if it's just a carbon-carbon double bond. So if it's carbon-carbon double bond, this is still non-polar. Okay, so this does not affect polarity. Zaitsev rule. Yep, that's a better way of spelling it. So I'm just making sure that I don't scroll past any question. So if there's a bond between an O and Cl, which one would you say is more electronegative? Well, according to the data, they're equally electronegative. So they will share the electrons properly. But you don't get questions like that in NCEA chemistry at all. Oliver asks, if a molecule has no suffix, no saturation, but has two prefixes that are the same number of carbons away from each other, which prefix gets numbering priority? The one that has got that comes up first in the alphabetical order. Like say, for example, like this. This is a Cl. This is a Br. How would you name this? Well, this is 1 bromo, 4 chloro, butane. And why is that? Because B comes before C in the alphabet. But this is like an achieved question. Okay, so don't lose sleep about it. And Alice 2021 level 2 question 3, pauses, get out of the stream, go find that video that I've done, watch that. You're better off that way. If the enthalpy is negative, then it's exothermic. Yes, I already answered this question, DPC official. Does volume equals mass divided by mass per liter? Does volume equals mass divided by mass per liter? Well, yes, if you look at the unit, yes. But I don't know why would you ever use that equation. Yeah, that's one of those enthalpy calculation questions, but it's like a one-off. Is graphite malleable and why? Graphite is malleable. Is graphite brittle? Brittle? Not really. It's not brittle. It's soft. It's not brittle. It's malleable. Like if you think about this, Alejandro. So if you think about the pencil lead in your pencil, that's graphite. That's literally graphite. It breaks quite easily, but if you drop that, it's not going to fall apart completely. So it is malleable because if you got two pieces of paper on top of each other, that's graphite pretty much. They're made of thin layers, so you can slice off a layer very easily. But once you got the layer, it's really difficult to destroy that layer. Okay, so malleable, you can like cut that into wires. Sure, you can cut it into wires. You can, yeah. Well, by definitions that we say that metals are malleable. But I'm trying to think, is it possible to cut graphite into thin wires? I don't see why not, to be honest. I think, yeah, you can, but it's not a very strong structure. That thing is going to break quite easily. What is a positive charged metal nuclear? Just protons and neutrons. Well, protons in particular. Just a positive center. Like my year 9s will know this. And if I say draw an atom, they'll draw the positive stuff in the middle, the negative stuff on the outside. Okay, so how can we identify salt that's carboxylic acid plus base reaction? User 1, 2, 3, 4. How can we identify a salt? I swear I've done this question when we did organic, man. Let's say if we have COH, whatever, doesn't matter what that is, and H2, whatever, doesn't matter what that is. So the salt, remember what acids do? Acids just donate the H away, and then the rest are just whatever, copy paste. How do you explain the effect of position if the overall pressure? Okay, so Malika asked this question. How do you explain the effect of position of equilibrium if the pressure is increased? So if you increase the amount of pressure, the system will shift to the side, will favor the reaction that produces less particles, gas particles. Okay, so if you, let's say if you have A plus B turning into C, and let's say this is gas, this is gas, this is gas. So if I increase the amount of pressure, then I'm going to favor this reaction. The system will shift this way because it is going to shift to the side that makes less gas particles to overcome this change. Where did you get the numbers for the electronegativity of elements? Well, I just know them. You don't need to know them. So you never need to know them. How do we do the scheme thing with polymers? I kind of just did that, man. So wind back a few minutes. How do you access level 2 chem on Discord server? That's just pick it roll. What diagrams do we need to know how to draw for structure and bonding? Just indo-XO ionic substance dissolving. Well, I'm assuming you know Lewis diagrams you need to draw, but indo-XO, yeah, that's pretty much it. Yeah, Emma, I think that's pretty much it, other than your Lewis diagrams and stuff. Why is graphite soft when the covalent bonds are strong? Like Amy, I mentioned this before. Just get a stack. Look at your book in front of you. Hopefully you have your notebook in front of you. So if you got those pages on top of each other, so each page is really strong, but the thing that's holding the pages is non-existent. Okay, so you can split that easily. When do we need to say dissociate in solution versus dissociate in water? Elizabeth, that's if you dissociating in water, you say it's dissociating in water. It's normally water that we use. Okay, so it's normally just dissociating water. How to calculate Kc? Kw you don't need to calculate. Kw is just H3O plus times, this is on your equation sheet, which is 1 times 10 to the power negative 14. To calculate Kc is the products divided by the reactants, and you need to make sure that this is only gas and aqueous only. Okay, so no liquid, no solid equations, no solid, no liquid species in there. What is that anti-marking thing? That's Zaitsev rule. Zaitsev rule, okay? It is needed. It's an excellent question. Anti-Markovnikov rule is a wrong thing to say about Zaitsev rule. If you look up anti-Markovnikov's rule, it's actually different to Zaitsev rule. Zaitsev rule is talking about in an elimination reaction, you make a double bond, and then the carbon with less hydrogen in the double bond. The carbon that will become a double bond with less hydrogen will more likely lose another hydrogen. So that's just the reverse of addition reaction. Just got here. How do you draw 3 repeating units? Just draw 3 of them next to each other and copy paste. Okay, so I'm just gonna speak like how do you draw 3 of them together? X, Y, A, B. Surely you can copy paste 3 units, X, Y, A, B, and you might, what is X, what is Y, what's A, what's B? Well, look on your paper, look at what they are, look at what the question is, because it doesn't matter what it is, as long as you understand that you just centralize your carbons in the middle and just copy them, and then what you do, you literally just do that, get rid of the double bond, get a pin, boom, 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 done. Okay. Yeah, just gets boring in the short way. Yeah. Is graphite malleable and why? Is graphite? I already explained that, man. Graphite is not malleable. It's not exactly malleable. Metals are malleable. Nathan, how do you calculate how electronegative element is? You don't calculate that. It's not a calculation that you do. Okay, it's not a calculation. They're just given in a data book. In Kc equations, you only include aqueous and gas. Yes. Does this include liquids, or are they different? You do not include liquid, Levi. Never include liquid. How do I know when a base acid fully ionized or partially ionized? For Kate, so if you need to know your strong base and strong acid, these guys will strongly dissociate. So they'll completely dissociate. Sorry. So the likes of HCl, HNO3, H2SO4, strong base like of KOH, NaOH. These are the common acids and bases. Okay. Graphite's not brittle. Yes. How do you calculate POH? How do you calculate pH? Remember, pH, this just means potential of hydronium. So potential in in chemistry is just negative log. Okay, just that. So how do we do POH? It's just potential of hydronium, negative log OH minus. Okay. What function group are given in preference in organic? So Stacy, anything double bonds is more important. Your alkenes, your carboxylic acid, they have double bonds, are way more important than your hydroxy, than your bromo, than your chloro, and those guys are more important than your methyls and your ethyls. Okay, can you go over pressure in equilibrium? So early on I literally just did that. So if you increase pressure, you favor the reaction that has less gas particles, and vice versa. All right. I'm pretty sure they don't classify. Yeah, graphite is not really valuable. I'm just trying to think about it in a reality way. You can technically, but it's not gonna last. Yeah, it just breaks instantly. It's not ideal. You can, but it's not gonna hold up. It's not gonna hold. Right, let's say if Kc is lower at 800, if Kc higher at 400, how's it endothermic? Okay, so Ji-hun, Mr. Kim or Mrs. Kim, you have asked a question that's excellent. So okay, so Kc, so look here, 800 degrees, 400 degrees. This is high Kc, and then low Kc. So this is low Kc, this is high Kc. So you just need to understand what's happening here. So when you have temperature that's gone down, so decrease in temperature, you favor exothermic reaction, okay? Because you are trying to release some energy to make up for the heat loss. And then can you see what we have here? Your Kc increased. So if your Kc increases, that means you have more products. That's what Kc stands for, products over reactants ratio. So this means you got more products. That means you have got, if you have more products, that means you favor the forward reaction. So here we know that when you decrease temperature from 800 to 400, we favor exo, and Kc increases, so we favor forward. Therefore, we know it favors exo, it favors forward. Therefore, forward is exo. Done. Excellent. Okay. Well, Stacy was not just in level 2 stream, she was in every level 1 stream last year as well. What's the difference in structure isomers and geometric isomers? So structure isomers are something like this. I can give you C6H14 and I can draw them like this. I can draw them like this. This is structure isomer. So it's just literally just same formula but being built differently. Geometric isomer is when you must have a double bond, and then the two things that's bonded to each of those two carbons, that's not drawn very well. Make sure your line's connected to the carbon. Like I said, this is cis, so you must have a CC double bond, and then the two groups bonding to each carbon must be different. Okay, so these two groups must be different that are highlighted. If they're on the same side, cis, opposite side, trans. So if you ask a question I haven't responded, just chuck it down again. How is the energy released in exothermic reaction even though the product enthalpy must be greater than the... No, you need to understand, exothermic energy has left. Energy has been released. So you have released energy, so you have less energy than what you had before. So this is exo. Okay, so that's for super out. How can an alkane be oxidized? Alkane cannot be oxidized into alcohol. Don't know who told you that part, but you mean alkene? Alkene can, alkane cannot. How do you describe covalent networks and bonds? Covalent network, like say the most common example of covalent network is silicon dioxide, diamond, and graphite. So we already talked about graphite quite a bit. But for silicon dioxide, each Si is bonding to two O's. Nice. Each Si is covalently bonded to 4 O's, and each O is covalently bonded to 2 SIs. So that just means I have a strong 3-dimensional network, and for diamond is each carbon bonded to 4 other carbons, and then covalent bond throughout the whole structure, and that gives you like a really hard, really strong structure. Okay, so it's addition. When temperature increases, temperature decreases, equilibrium, and temperature decreases, the equilibrium, are they both forward favored? No, Sasha. Temperature, when you change temperature, you need to look at this number here. So it could be whatever, but you need to look at this. You need to look at the enthalpy. Increase in temperature favors increase in temperature favors endothermic, decrease in temperature favors exothermic. And how do you tell if it's endo or exo? When you're going this way, this number indicates that. So if it's a positive number, that means it's endo. If it's a negative number, that means it's exo. Okay. Well, if you, I'm a bit worried that if you guys are asking this sort of question the night before the exam. Yeah. What is 10 to the power negative pH? Tim Tam, that's for the hydronium ion, H3O plus. On the Learn Culture video, no, that's not true. They probably made a typo. Alkene turns into alcohol. Okay, so this is oxidation. So this is using MnO4 minus / H plus, or you can just use MnO4 minus neutral, which is correct. That if you're using different time was okay. So for that one, Jihan, you got those two salts. So CH3. So you got CH3, CH2, and this is actually not a bad question. You got this versus this, right? You're asking me which one that you would use. Now the question is, now remember these are all products of reacting with base, right? So most of the time, this will be more correct, because if you don't, like say, if you react with KOH, where the hell would you get the Na from? That would be K. So Na is specifically talking about sodium hydroxide. If you have no sodium hydroxide, or sodium oxide, or sodium anything, where would you get your Na from? Which reagents require heat? Not that many in year 12, no. Okay. Yeah, cracking does. Alkane to alkene does, but that's about it. I thought addition reaction only occur with alkenes. Yes, you're right, but alkane can also be oxidized. Guess you learned something new the day before your exam. Can you discuss the type of reaction that occurs with bromine water is added to alkane, or alkane can distinguishing? Okay. So that's one of the most popular questions. I can normally bet my house on it. Yeah, every year with my year 12, so I said this question is always going to be in the exam. So I'm just doing the basic part. Okay, so what's going to happen with us? This is addition reaction. Why is it addition reaction? Because the Br2 is added across the two carbons. You break the double bond, and then you don't need any UV light like we're doing right now. And this is a fast reaction. It goes from orange react to colorless very, very quickly, normally straight away. Whereas CC with Br2, this will do a substitution reaction. So you just substitute one of the H's at the end, not in the middle. Could be either H's at the end. And then this is substitution reaction, and this reaction is very, very slow, and you need UV light to help that. Okay, how do we calculate hydronium ion and hydroxide ion concentration? That is pH equals negative log H3O plus. H3O plus equals 10 to the power negative pH. This should be on a resource sheet. Okay. All right, good night. Bye-bye. Could you please go over the length of carbon chains and how it affects each functional group? Okay, so you just need to remember the carbon chains. The longer the carbons, the longer the carbon chain, lower the solubility. The lower the solubility, the higher the melting point and boiling point, and that's all you need to know. Okay. When the equilibrium is cold, is it no. When the equilibrium is cold, the system will favor exothermic reaction, because you lost heat energy and the system will try to release heat energy. How do you describe covalent networks and bonds? I did it just now. That was your question. If it gives a yes, I'm reading onto there. Yeah, sorry if I'm reading probably like chat, so you typed in like 5 minutes ago. Yeah, I already done that. Which organic substances are soluble in water? So your alcohol, short chains, carboxylic acid, and amine. These are soluble in water. The others are not. Okay. I already done that. When do you add CO minus in acid base reaction? Well, why does sometimes metal cation bond to where the negative would be, but not always? So for all of us, so this is what I mean, right? So I can react this with any base. Like say if I react with KOH, what's going to happen? It will be COO minus plus K plus, and can you see this is where you can write it like this. This is totally fine. And some people prefer to join them together. They go O minus K plus, and then they neutralize, and this is how you do salt. But you know, you can write them separately. You don't need to put them together. No one said you have to put them together. Okay, how do you compare the conductivity of different solutions? The more ions they have, the more the higher the conductivity. So this is looking at weak acid. You know, if you look at weak acid, like say HA plus water, partially dissociate into A minus plus H3O plus. This is a crappy conductor because these free moving ion concentration is very, very low because it partially dissociate. Stacy already answered that question. Why do non-polar molecules not dissolve in polar? Because they're not strong enough. Okay, so if you got polar, let's say A and B, for example, A and B, this is slightly positive, this is slightly negative, and then you got like C and D, just C, for example, C hanging out with C, more C's. So these guys are non-polar, they don't have any charges. So you can see that, you know, between the A and B partnership, can you see this is positive, this is negative? This interaction is stronger than this interaction. If you're asking this question, seriously, go read some of the, go find the question on the old exam paper and watch that section of my video. You're asking an excellent question, and I don't have a lot of time tonight to go through that. Okay, so Toby, so finding exam question on that, I go through that very thoroughly every single year. Okay, can you please go over some more stoichiometry? So that's calculation questions. It's best that it's literally like say, for example, again, I'm just gonna do it really quick. This is just, again, the best way is that you grind exam papers. If you grind the past 5 exam questions, then it shouldn't be too hard. Okay, like say, for example, I have 5 grams of A. All right, how much energy? How much energy is released? How much energy is released? Well, absorbed, this is negative. Released, let's go with negative. And I know the molar mass of A is 2 grams per mole, for example, just making this up. All right, so you need to look at this equation. You need to find A because I'm interested in that. So look here, so I know that 2 moles of A give me 10 kilojoules. So that means 1 mole of A give me 5 kilojoules. And how many moles do I have? I know I have 5 moles. 5 divided by the molar mass, N equals small m divided by big M. So this is 2.5 moles. Okay, so I know 1 mole gives 5 kilojoules. I have 2.5 moles, so it's 2.5 times 5. So I get 12.5 kilojoules of energy. Yeah. All right, I'm not doing any more calculations. If you want more calculation, pause the stream or leave the stream and find a video in the old exams. It's better, way more productive to be using your time that way. When do you add CO minus in the acid-base reaction product? Why does sometimes middle? I already talked about this. I already talked about that. Okay. pH to H3O plus is 10 to the power negative pH. Yeah, that's someone who's already answered. Could you also please go over amine and organic acid and how do you name it because it came up? Again, if you go back to stream, you would have seen that. Maybe I already answered your question. Naming it, like, what would you call this? I swear this is the last time I'm doing amine questions with carboxylic acid. You guys like actually my students who don't pay attention in class. All right, so what's gonna happen here? This becomes that. This becomes CH3COO minus. So what is this called? This is called ethanoate. You started with ethanoic acid, now it becomes ethanoate ion. This becomes NH3 plus CH2, like say for example, so CH3. So this is methane. You can say 1 ammonium methane or methane ammonium. You do not need to name this. I don't know why you're so obsessed with doing things that you're not required to do. But yeah, sometimes they like to ask you one-off questions. So yeah, do you have to say this would increase the yield, increase the amount? Elizabeth, I'm not sure what you're asking. Well, I'll do level 3 tomorrow, probably not. I mean, there's more than enough content on my channel for you to do level 3. When the equation, Stacy already did that. Okay, so Stacy, when the equilibrium is cooled, the exothermic reaction is favored. Okay, stop spamming that question. I got a question to draw the cis version of geometric isomer, but on one side the C was bonded to Cl and CH3, the other side the C was bonded to Cl and CH. So you just put the Cl's on the same side, but we don't care what this is. There you go, cis, done. This is cis, same things on the same side. What about observations for the bromine water? Goes from orange to colorless with alkene straight away. Alkane needs UV light, does that in a few minutes. Why is it when CH3COO and A fully dissociate? Okay, so Rainbow Gaming, you got a question here that is actually a pretty good question. You got mixed up with the terminology here. So if you got CH3COO and A, this dissolves. It's not dissociate, it dissolves into CH3COO minus and Na plus. And then this further partially dissociate to CH3COOH and OH minus. Okay, so why does the Kc value only change with temperature? Because Kc value only changes with temperature because with changing temperature, you change the amount of energy. When you change the amount of energy, you have essentially changed everything. Okay. No, I already done enough calculations. You can look at the more calculations later. Because with the calculation questions, it's better that you look at how the wording's done, like with the A's and B's, and it's so Cristiano, like seriously, just open up all the exam on your computer, find the video on my channel that's going through that question, give it a go yourself. If you can't do it, listen to how I do it. Okay. Why does long chain have low solubility? Because the more carbons you have, the more non-polar it is, therefore the less soluble it is. What are the states for each of the reagents? I don't know what you're trying to ask here, Kendra. Each of the reagents. You're asking, no, there's way too many reagents. Just look at the flow chart and then you can see it there. So could you please go over aiming? Yeah, already done that. Carboxylic acid. See, for carboxylic acid plus NaOH in the flow chart, why is the answer only, so Stacy, so technically if you did CH3COO-Na, they cannot mark you wrong because that is correct. Okay, so Toby gave me another one. Only because you put the question in. 2NO. This is 180 kilojoules per mole. Is it negative or positive? Negative or positive? Calculate the mole into that react to produce 90. Oh my god, this is not even an NCEA question, surely. So you're producing 90 kilojoules. How much N2? So you just look here. Which species am I interested in? N2. So find N2. Look here. 1 mole of N2 is 180. All right. Now, how much energy do we release? 90. How much N2? Half. Done. All right. No more calculation. So could you go through POH? I'm confused how to use it. Kaiji, if you are confused about how to use POH the night before the exam, I would highly recommend you to stay away from it. Okay, not worth it. Not worth it. It's if you know how to calculate the pH of base, like say if you know the OH minus, and if you just do use KW divided by OH minus, if this is how you've been taught, you get H3O plus, and then you just negative log this number to get the pH. If you know how to do that, just do it that way. Okay, because the day before the exam, it's not worth it. Do we need to know incomplete combustion? Well, complete combustion, you make CO2 and water. Incomplete, you just make carbon and water. Yep. If the energy for the equations, if it's negative, is it XO? Yes, it is. Stacy, if it's positive, it's Indo. Yes. Could you write down the order which is given persons? If they're all present, so the most likely chance, the most likely thing that you will get is, I say, I've gone through this with someone today. I say something like this is OH. So So this is more important. So this is called 4-hydroxy butyne. Okay, because your double bond is more important. Just always remember double bond is more important. All right, have a good night, Ash. See you, man. What's the reagent for alcohol to haloalkane? That is KOH, no, nice. That's SOCl2, PCl3, or PCl5. That's the answer for Jamie. Everyone thinking? No worries, no worries. What were the atoms that don't need 8 electrons? That's Br and Be. Joshua, not Joshua, ABC, so B, not Br. Beryllium only takes 4. Boron only takes 6. How do you identify conjugate acid base? So use ABC, I'll just do it right here. All right, look at that. Which one's the acid, which one's the base? Figure it out and type down in the chat. Could you do organic chemistry? I did an organic chemistry stream. You were in there. I'm pretty sure DPC 1 to 3. Just look at it, man. I'm not going to do an entire topic in less than 20 minutes when you spend 2 hours on 5 weeks on it. Yeah, SOCl2 is by far the most important one. It's the most correct one as well. In organic, is there a rule to remember which reaction needs to be heated? No, year 12 heat is not a big thing. I'll tell you that right now. Year 13 is a big thing. Year 12 heat is not a big thing. Could you explain what happens to the equilibrium when pressure volume increases? I swear to God, that's like the 5th time I've seen that question in the chat. If you increase pressure, okay, ready? So if you increase volume, you have decreased pressure. You want to favor the side of the reaction. You want to favor the reaction that will produce more gas particles. Okay, so 5th time for the day. Stop asking about pressure and volume. Wait, so for polar not dissolving in non-polar, do you not say the energy between the polar particles is greater than the energy between the non-polar? Ghosty is kind of like this, okay? So you have polar and polar stuff mixed together. You have non-polar stuff mixed together. Why don't they dissolve? Because the force of reaction between the polar stuff and is stronger than they would react. You know, they don't want to hang out with the non-polar. This is weaker. So this is stronger, so they don't want to mix. Okay, that's why. So it's always good to say, you know, why do something not dissolve? You just say the force of attraction between the molecules in the existing solution is stronger than what they could become, therefore they don't do it. Okay. What given the OH group or halogen group? OH group is probably better. And Stacy, again, you're getting way too hang up on like achieve questions that will probably never come up. You know, not worth losing sleep over. Okay. For reagent from alkane to alkane, should I use HPT? You shouldn't use any of those. You should use H2PT or H2 nickel 150 degrees, not H. Are you just doing structure bonding? I'm doing everything, man. Yeah. Do we need to explain why the longer carbon chain will make the boiling point higher? Annabelle, you do not need to do that. Well, if they ever ask you, you just need to say there's a stronger intermolecular force. Done. That'll be more than enough. That's like level 3. Okay. Should I use NaOH or KOH? Which one do you prefer? Just pick one and run with it. What's considered a longer carbon chain? Like, yeah, greater than 5, 6, 7. Yeah, because the thing is the questions being thrown at me left and right. I don't have time to go through I mean, this is what we're doing, right? So literally last minute if you have any questions. Why is there a double bond attached to oxygen in the carboxylic acid? Because that's their functional group. That's just the way they are. Why do we have 4 limbs? Why does a computer require electricity? You know, just that's how what defines them. No problem. Good night. Which organic reaction requires H2SO4? So for Jamie, so you could have diluted H2SO4 going from alkane to alcohol, or you could have conc H2SO4 going back, so going from alcohol to alkane. You could use H2SO4 to No, that's year 13. That's about it. Okay, the rest is all year 13. I'm doing level 1 English before level 2 came. Well, just it's English. It's just English. Yeah. Yeah, I made it to the bottom. Yay, live chat. Yes. Yeah. Sorry, just a bit of a backlog. Let's just see. Someone typed stuff for me. NCEA why is there NCEA's announcement? Jeez, never mind. Does KOH alcohol require heat? No. How do you find the pH of water when the KW has been changed? How do you find the pH of water when the KW has been changed? E.g. KW equals, okay, because KW equals H3O plus times the concentration of OH minus, right? So if your KW is a different number, so it's pretty much in water, you know, you did this in level 1, H3O plus and OH minus is the same. So make this x. Can you see this is x, this is x? So x squared equals kW. Okay, so your kW is 0.114. So you just square root that number to find H3O plus and negative log. That's your answer. For chemical reactivity, when do you use higher proportion of occlusion versus higher frequency of occlusions? Matt Champ, so you would always, when you want to talk about why there's a why there's a higher resurrection, you just always talk about higher frequency of successful occlusion that will result in a higher resurrection. The higher proportion is to do with temperature explanation. So you're mixing two things together. Which organic compounds are soluble, which are insoluble? So Ella, alkanes, haloalkane. Let's do the other way. Carboxylic acid, alcohol, amine are soluble. The rest are insoluble. So that's for Ella. Why is the product H2SO4 in the presence of water S2O4? Well, it's not SO4, it's SO4 2 minus. Because thus, you need to dissolve, you need to give away both of the H's, so it's SO4 2 minus, oops, plus H3O plus, and I mean, you do this in 2 steps, okay? Let's do this in 2 steps. It's actually not a bad question. Okay, so you make that, and then your HSO4 can do it again. They can do it again. Oops, so this is gone. So you're not wrong there. They can do it, you know, your HSO4 minus is in the middle. But for that to go to completion, it goes all the way. How do you name the ion formed by amine when it reacts with carboxylic acid? So you said propan 1 amine plus ethanoic acid. You will make propan 1 ammonium plus ethanoate ion. Okay, super outlet. Propan 1 ammonium plus ethanoate ion. How do you tell something's polar? That's like a whole excellence question in one sentence. How do you tell something's polar? Because it has polar bonds and the shape is asymmetrical there. Well, if you write that, you're not going to get excellence, but that's a good starting point. Does KOH, conc, NH3 alk, Stacy, none of the... technically, NH3 alk with heat will help. So I've seen NH3 alk with heat helps. So yep, the other two don't need heat. What solution are polar, non-polar? Yeah, already. Yeah, what solutions are polar? So that's to do with the. This is actually a slightly different question. So your alcohol, your amine, your carboxylic acid. You know why they dissolve in water? Because they're polar. So there. You don't know how helpful. Nah, no worries, Ghosty. It's all right. Have a good night. Good luck tomorrow. Good luck tomorrow. Where did the extra H plus go in the second equation? Huh? What do you mean, Amy? Where did the extra H plus? What do you mean extra H plus? It went from here to here. one of these, one from here to here. So you can see I made 2 moles of H3O plus. So if you're asking about conjugate acids and base, well, actually, let's do one that you all know. You did this in year 11. So Ash, I want you to think for yourself. Which one's the acid? Which one's the base? I want you to do this. I want you to actually find the trend. Okay, so Ash, there's your question. Do that for me. Which one's the acid? Which one's the base? And find me the trend. What's the difference? What's common with these 3 combinations? Right, will alcohols react with non-acidified permanganate or potassium dichromate? Yes, it can react with non-acidified potassium permanganate, especially, which makes MnO2, which is a brown thing. But again, not a very popular question. Can you discuss how to draw the salt form during the acid-base reaction from? This is like, again, the 10th time I've seen that question. You just look at this. Literally the 5th time I've drawn this. Look at this. I don't care what those are because that's not the functional group. Okay. So what does an acid do? What does a base do? What does an acid do? An acid will give away the H, so you're left with COO minus. And where did the H go? It went on to the carbon, the nitrogen, and then it has a positive charge. The rest is the same. So what is this called? This is something 08. So let's say there's 1 carbon here. Let's say, for example, 1 carbon here. So there's 2 carbons. So this is ethene, no 8. And this is whatever amine. So it becomes whatever ammonium. Stop worrying about naming these. You're not required to name these. I actually never seen you that you need to remember. Maybe once out of like 10 years you need to name them. But your amine, like say this is 1 amino ethane. And so it just become 1 ammonium ethane. Like just remember like that, okay? So could you go over the year 11 stuff like acid plus base, acid plus carbonate, acid plus metal? I would rather not, Stacy. The only reaction you need is acid plus carbonate, which makes carbon dioxide and salt. Does electronegativity increase the number of carbon atoms? No, it does not. The electronegativity does not increase with the number of atoms. Has no reference, it has no influence. When you can dissociate ions twice, like you did before, there are a lot of ions present, so can we say that's the reason we can conduct? Yes, of course. But it is a strong acid, okay? So in comparison, that's actually a good point, good, good observation. So if we look at these guys, so you can see that for H2SO4, can you see we made 2 lots of H3O plus? So H2SO4 typically has a higher solid conductivity compared to other acids because you make more ions. So Ash came back with the answer. Yeah, there you go. You figured it out. Now you will remember, because not that I told you to memorize something, but you figured it out. There you go. So it doesn't matter, like I could give you anything, man. I can give you HF, F minus. I can give you CH3, NH2, and then I can give you CH3, NH3 plus. It doesn't matter. You just need to look at them and then look at which one has more H plus, and that is the acid, okay? Alkene plus HCl. Alkene plus HCl. Alkene plus HCl. You just break the double bond and then add the H and add the Cl. If it's asymmetrical, you can draw it 2 different ways. Okay, major minor products. Do you have to do 2 equations for H2SO4? The thing is, guys, you never get questions about H2SO4 because of the fact that it's complicated. You don't get H2SO4. Yes, didn't I see if I said your name right? Strong acid that dissociate twice. Yes, it does, because you have more ions. Okay, so but that again, that's no one asked you that question in level 2. Ash, so HCl will be the acid. Yes, Cl minus will be the conjugate base. Okay, so they are like combining together. No, see you DCV 1 to 3. Good luck tomorrow. And are exceptions to octet rule? Nitrogen dioxide, something that we have to worry about in bonding and structure. I'm not following. What's the octet rule? Octet rule means bond to 8. So the only exception that bonds to 8 that you know is these two. This is 4. This is 6. Why does it not make an alcohol just because aqueous HCl is acidified water? Wait. Sorry, Jules. If I aqueous HCl. Oh, that's a main question there. So if you got alkene plus aqueous HCl, that's just, so essentially just that, right? That's what you mean. So yeah, you make alcohol. Yeah, this is just H plus. It could be H2SO4 HCl, but no one uses HCl. It's just not a common thing to do. All right. See you guys. All the best. All the best. All the best. All the best. Conjugate base is the thing that is produced. Like if you can identify the acid and whatever it turns into is the conjugate base. Okay, could you please a server link? Where is the server link? Invite people. Copy. Here it is. Oops. But could it not also make an haloalkane? No. If you decide, if you say to yourself, it's acidified water, which is a funny way of wording it, but it's essentially an acidic condition, and the water is the active ingredient. Okay, so you're more correct that way. If you are talking about, because it's more of a, now so this is more of a tricky question, because you're saying you've got HCl and water. So technically you're looking at, with the alcohol side, you're looking at this reaction, you're treating the H plus as a catalyst, which makes this happen, which I personally think will be more appropriate. Okay, so if you're solely looking at alkene plus HCl, then there must be no water. Okay, and that will make you the haloalkanes. Okay. Yeah, I don't like this acidified water. Yeah, it's just you just have water with the acid dissolved in it as a catalyst, that will initiate an addition reaction. Okay, so if you talk about HCl only, Jules, that's you're correct. You make a haloalkane. But if you say HCl/water, no, you got water in there, and that changes the thing. Okay. But isn't HCl more reactive than water? No, but you got to look at the active ingredient in here. So when you got the water, when you got the HCl that's not so concentrated, when you're dissolving a lot of water, and then you put that with the alkane, and then you got the hydroxy group and you got the chlorine group, which one is more of a better, what we call leaving group, and they'll join the thing. In this case, it's just going to be the OH, man. Like you're reading way too much into this. Okay, it's a good thing, you're not doing it for the sake of exam, but you just need to remember, if it's H plus, any acid with water, it's this guy that's more reactive. Okay. But if you're just saying HCl, then you go haloalkane. Okay, you go haloalkane if you're just doing that. Why is HCl aqueous acidified water? Because it's acid dissolved in water. Yeah. When calculating pH equivalents, how do you know if you should use a Ka or Kb? That's year 13. Please don't ask year 13 questions in here when you have a whole bunch of year 12 that has the exam tomorrow, and when they see that question, like, what the heck? So that's a year 13 question, not gonna answer that. I've already gone through 2.4. Avani, I've just literally been answering everyone's questions. There have been like 1 million questions, and half of those are the same questions. So yeah. Can you talk about what giant covalent networks have directional and non-directional attractions, and how do we need to relate this to the solid? If you are talking about giant covalent network, Alejandro, you do not talk about directional or non-directional forces. Directional and non-directional only applies. So directional only applies to ionic, and the non-directional only applies to, I mean, they're all directional except metallic, if you want to think about it that way. But for the sake of examination, this is all they ask you to compare. Okay, so when you talk about covalent bonding, non-directional, the directional nature is not something you need to consider. Okay, so it just means that carbon bonds with carbon. So of course it's directional, because once it's carbon bond with that carbon, they're not going to be able to bond with, you know, some other random carbon. You know, once they're fully saturated, once they're fully bonded, they're set. They're not going to bond to anything else. Okay. So in the 2020 exam, okay, I'm actually going to find this, because this is getting, let me find it. Let me find that question. Because if they ask questions like that, then it's a bit mean. 2020. 2020. Question 1D. Okay. So this is where, now there's a big difference here. You see they put HCl AQ. They did not say HCl/water. And there's a big difference here. Okay, so so with HCl AQ, you are going to go to the haloalkanes. Okay, because they're emphasizing the importance of HCl here. So if you say HCl H2O HCl /H2O, which is a horrible way of putting it, because they should have just done H+/H2O, and that's when you would go to the alcohol. Okay, hopefully that makes sense. Yeah, hopefully that makes sense. Because you can't imagine, like, any concentration of HCl, you will have some water in there. So you're definitely gonna have some water, but so it just solely depends on, you know, what you are looking at, which concentration, and then the reactivity side of things. So you're comparing the Cl and the OH1, and you're trying to think about which one's more reactive. Yeah, that's just, yeah, hopefully that makes sense. Any tips for going through the paper fast? Know your stuff. If you know your stuff, you go through them fast. Yeah, I'm not doing level 3 stuff. Yeah, I'm not doing level 3. I got plenty of content for level 3s. You guys have, the level 3s have actually got the most amount of content on the channel. The covalent network can conduct only graphite. Only graphite. Do we need to know table vines? It will help. However, to be truly scientific, we produce a mixture. Yes, Jules, you need to, you know, if we want to go into the whole mechanism side of things, if you're interested in that sort of stuff, then you can look at how reactive the chlorines are and how reactive the OH groups are in terms of their ability to attack those carbons when the double bond breaks. So you're definitely right there, you know. So that's a little bit, that's way more complex than the level 2 chemist, but you know, you're definitely on the right track. I think you'll be a good chemist. Don't just learn for the sake of exam. No, you will do well. I can tell already. Okay, I can tell. You're finding a lot of interest in the subject. I can see. No, that's good to see. Would you work through the reaction scheme and kind of explain it as you go? Should I do this one on the board? This one right now. I already did 2020. I did all these reaction schemes. So you can just find one in the old exams. You know, you can just find one in the old exams. How do you calculate the quotient on the equilibrium system and use the quotient? Okay, so you're trying to talk about Kc. Okay, so A plus 2b turns into 3c, and let's say 3C, and all of these are aqueous, and this is gas. Like I say, it doesn't matter, aqueous or gas will work. So how to write the Kc? Kc equals the product, which is C to the power of 3, which is us, divided by A times by the concentration of B to the power of 2. There you go. How do you calculate that? Just substitute the numbers in. If I told you what ABCs are, you can just go through that. Let's speed run. I mean, I already done it, so I mean, I already opened it, but this is not printed. I can't type on this. So you can have a look at the. This is a 2020 exam. You can find it on my YouTube channel. Can we go through polarity for 2.4? It's something that I believe you can do if you give me 1 sec. No, don't play. Polarity, have I done polarity? No, actually I have not done polarity on my channel. Have I done it here? Hold up, let me just see if I've done it here. Oh, I see the thing. Your 12 shapes, your 13 section, never mind. For the polarity, so if you're looking at the answers, like a model answer, you just need to talk about the bonding between the atoms, which creates a polar bond, create bond dipoles, and then you talk about the shape. If it's symmetrical, dipoles cancel out, non-polar, asymmetrical, don't cancel out, polar. Okay. What questions about the properties of giant covalent do I need to know? Alejandro, for giant covalent network, you just need to know they have extremely high melting point. They are not malleable, they're not ductile, they don't conduct electricity except graphite, and they don't dissolve in water. Very boring. And why is that? Because of the very strong covalent bonding throughout the structure. Okay. All right, so it has been an hour and 5 minutes, 10:30. I think it's a good time to probably end the stream, because I do want you guys, like, nothing's more important just to clear your mind before the exam, have a good night's sleep, maybe even wake up, like say half an hour earlier, just to, I don't know, last minute cram a bit more, but you know, a good night's sleep is really, really important. Graphite conducts electricity because of its layers. Nope, it conducts electricity because the free moving electrons between the layers. Okay. I don't know if you're answering bonding, but how can you exactly know molecular polar without knowing the exact? Okay. So this is, Valeria, this is for the sake of exams. Okay, for the sake of exams, literally like this. If you see two atoms, if you see two, like say AB2 for example, if you see two atoms that are different, you would know the bond. You just assume the bond between A and B is polar. Why is that? Due to significant electronegativity difference between A and B. Which one of those is more electronegative? You don't need to tell me. Okay, you don't need to tell me. Could you go over the solids? So solids, you got metallic. Stacey, are you in that? What do you call it? Are you in that that NCEA server? You should be able to go to the level 2 chemistry page and find the pinned message, and then you should be able to find like a set of answers that I've done for solids. It's much better just to read that. Okay. Yeah, at level 3, when you go to level 3, Valeria, we will actually teach you how to figure out which one's more positive, which one's more negative. Okay. Can you talk about trend of alcohol carbon chain? So more carbons to the top here. If I can find it through my horrible handwriting. There you go. No, not that one. 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 Oh, it would have been easier if I just did it. Oh, there it is. So number of carbon chains. The longer the chain, the lower the solubility, the higher the melting point, the higher the boiling point. Because of the more carbons there are, the higher the force of attraction. That's why you need more energy to break them. And then the more non-polar stuff you have, which is, you know, yeah. Can you talk about the trend in solubility? Already done that. Sweet. No, I'm gonna, you know, otherwise if I stay here, I'll keep getting questions. but it is getting late into the day, so all the best with your exams next tomorrow. If you're doing level 3 chem, you know where to drop by next year if you struggle. Yeah, it's yeah, no worries, guys. All the best, you know. I hope they give you nice and easy questions. They did that for the level 1s, so hopefully you get a bit of luck this year on your side as well. But thank you for tuning in. All the best tomorrow, and yeah, I'll see you guys next year if you do chemistry again. But have a good evening. Good luck tomorrow.